Here is a nice Canadian Mathematical Olympiad, edition 1971. Here is the following information. Find all real values of a such that we have two functions. The first function f of x equals x squared plus ax plus number 1. The second function we have is set as g of x equals x squared plus x plus a. Start with this one by solving this equation, because the common root for both functions is solving the equation. If you put f of x equals g of x, so meaning these functions, they are going to meet at some points. Okay, so which means we are going to solve this equation. So we have f of x equals g of x equivalent, which means I will have x squared plus ax plus number 1 equals x squared plus x plus a. Okay, so it's very clear here, x squared will be cancelled out. Okay, then I'm going to move over x to the left, so which means I will get a minus 1 factor x. By moving number 1 to the right, we'll get a minus number 1. So I'm simply going to, then I'm going to move over a minus 1 to the left and make a minus 1 as a common factor. I will have a minus 1 factor x minus 1 equals 0. Okay, here is a problem. You may have a minus 1 equals 0 or a minus 1 not equal to 0. So we are going to show a minus 1 not equal to 0. So by the way of contradiction, suppose a minus 1 equals to 0. Okay, in the other word, a equals 1. I'm going to take this value of a and insert it in both equations to see what's given us. F of x equals x squared plus x plus number 1. I get g of x equals x squared plus x plus number 1. So both functions turn into one function because they are the same. Okay, so I'm going to factor out this one. So we get here f of x equals g of x equals x squared plus x plus number 1. I'm going to factor out this one. It's giving me x plus half quaternary square. If I'm going to distribute this one, is giving us x squared plus x plus quarter plus 3 over 4. This one is strictly superior than 0, which means we have no roots. No roots, it's which is contradiction, because this one it contradicts our information, because both functions supposed to have at least one root, but we found no roots, which means a minus 1 not equal to 0, which means the other word a different than number 1. Okay, which means x minus 1 equals to 0, which means x minus 1 equals to 0. In the other word, x equals 1. X equals 1 is a common root of both functions. Okay, so since both functions have one common root here, which is x equals 1, this one is going to be written on the form of x minus 1 factor something. Okay, I'm going to put it here as I'm going to put this one as mx plus n. Okay, so for the second equation, second function is going to be written on this form. Since they have the same root, we'll get x minus 1 factor and g of x equals x squared plus x plus a. Since they have the same root, which means is going to be written on this form, x minus 1 factor px plus q, like this function. I'm going to distribute both functions. For the first one is given as m is multiplied by x squared. Then by putting this term is multiplied by this term, and this term is multiplied by this term, by putting x as a common factor, I get here plus n minus m is multiplied by x. Okay, minus the last term, which is minus n. For the second function, I will have px squared plus qx minus px which means I will have q minus p is multiplied by x plus the last term, which is minus q, like this. Now I'm going to put a like numbers, coefficient with coefficient, order with order, so as we have here. So for this function we have number 1, m equals 1. Okay, for the second term the coefficient a equals n minus m. For the last one, n equals 1. For the second function, p here equals 1 and q minus p equals 1 because we have the coefficient 1 here. So the last term, a equals q. Now I will have two equation system. The first equation system is involving, I have m equals 1 with n minus m equals a. The last term, which is n, which is minus n equals 1, which is n equals minus 1. So I will have the second equation system. For the second function, I get here p equals 1. I get q minus p equals also 1. The last one, q equals minus a, because we have minus q equals a, in the other word q equals minus a. I'm going to solve each one. I'm simply going to replace the value of m into the second equation, which means I get n minus 1 equals a. By taking this value of n and insert the first equation, I get here minus 1 minus 1, which equals minus 2 equals a. So I found the value of a equals minus 2. To solve the second equation, you may have another value of a. We check it now. So I'm taking this value of p and insert it into the second equation. I get q minus 1 equals 1. In the other word, q equals 2. By taking this value of q and insert it in the last equation, I get a equals minus 2. Both functions even as the same value of a, which is equals minus 2. So I'm going to write f of x. How I'm going to write the f of x? By replacing this information into the function. So for the first function, f of x, I get x squared plus minus 2x plus number 1. This one is written on the form of x minus 1 quinary square. For the second function, g of x, by replacing minus 2 into a, I get x squared plus x minus 2. So we'll get x minus 1 here as a common factor. P will be replaced with number 1, which is x. Q will be replaced with number 2. So we'll get 2 here. Okay? I found only one value of a, which makes these functions to have the same common root, which is x equals 1. Okay? So I have ended this video. By the way, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video.